Right, this video covers the introductory notes. First, a short bit of background on civil engineering hydraulics involving water services, supply of potable water, drainage and flood control. But what is hydraulics? Right, a fluid is inelastic in shear. It continuously deforms under application of a shear force. The rate of shear strain, of course, in Afrikaans is tempo van skuifvorm. So figure 1.1 shows you a nice image about surface tension, but when we get to properties of fluids, this is really the important stuff that you need to learn. You must know all those definitions off by heart. Getting to units, we need some or other standardized framework of units by which we can measure quantities. And this is an important aspect that hopefully you have addressed before getting to hydraulics. So we have the 6 primary units in the SI system. Of these 6 primary units, we use only 4 in this module: length in meters, mass in kilogram, time in seconds, and temperature in Kelvin. And then we have derived units. So we have the principal ones that form the basis of the derived units. Just a quick side note on notation in this textbook. You may be used to L over T, but the textbook uses the notation LT minus 1, which of course is exactly the same thing. Looking at the derived units, we are dealing with velocity, acceleration, force, energy, power, and then various properties of fluids, including of course density, which is a very basic one, and then specific weight, relative density and viscosity that we'll deal with more in chapter 3, and finally also just touch on surface tension. Right, then a note on dimensional analysis. Entire textbooks are devoted to this topic, and those who will be dealing with scale models in the lab will definitely delve into this. But let's just consider a brief example of Newton's second law. Simply evaluate the dimensions of each parameter in the equation and compare the two sides.